What would happen if we turned the moon into a planet of pure water with the same mass? Alright, let's transform the moon, all 73 quadrillion metric tons of rock, into pure water of equal mass. Whoa, its appearance would change right away. Its radius would expand from 737 kilometers to nearly 500 kilometers. Its apparent diameter would increase by nearly 50%, turning from a small silver plate into a translucent jade disc. At night, it would light up the roads so much you wouldn't need streetlights. It would even look like it's breathing. During the day, the lunar surface temperature would soar to 127 degrees Celsius. In a vacuum, ice would boil instantly, releasing a thin layer of water vapor, like wrapping it in a white veil, and its brightness would soften. At night, the temperature would plummet to minus 173 degrees Celsius. The water vapor would then condense into ice crystals and fall back to the surface, making the ice shell shiny again, like a glowing snowball. This breathing layer would form a thin atmosphere. Because the speed of water molecules is far lower than the escape velocity of 2.4 kilometers per second, they won't escape all at once. What's more, the water on this water planet would exist in three forms. At its core, 500 kilometers deep, the pressure, 400 atmospheres, would squeeze water into ice 7, which is harder than steel, like a water diamond hidden at the center. The middle layer, 500 to 500 kilometers deep, would be regular ice, as brittle as fully frozen ice cubes in a fridge. The outermost layer, 100 kilometers deep, would be the active zone, boiling during the day and freezing at night. But don't worry, the tidal force wouldn't change. Since the moon's mass wouldn't change, its gravitational gradient on Earth would stay the same. People who go tide pooling could still wait for low tide on time, and the Qiantang River tidal bore would still arrive as scheduled. The only downside? It would slowly lose weight. Without a magnetic field to block the solar wind, a small amount of water molecules would be blown away. But the mass lost each year would be less than 1/quadrillionth of its total mass, so it would remain Earth's bright neighbor for 10 billion years.